You take one bite of something spicy. At first, everything's fine. Then, there it is. Your tongue starts burning, your forehead starts sweating, and suddenly you're looking for the nearest drink like it's an emergency. But the strange thing is, the food hasn't actually become any hotter. You could check it with a thermometer, same temperature. So why does your mouth feel like it's on fire? The troublemaker is a chemical found in chili peppers called capsaicin. And here's the first surprise. Spicy isn't technically a taste. Sweet, salty, sour, bitter, and umami are tastes. Spicy is closer to a chemical version of touch. Scientists call it chemostasis, which is a complicated word for chemicals creating sensations like burning, cooling, or tingling. Inside your mouth are sensory nerve endings containing tiny channels called TRPV1 receptors. Think of them as microscopic heat alarms. Normally, these alarms react when temperatures become painfully hot. The channel opens, the nerve fires, and an urgent message travels toward your brain. Hey, this is hot, do something. Capsaicin can open that same channel. It's basically like having a key that fits the heat alarm, even though there's no actual fire. Your nerve endings don't send your brain a detailed explanation. They don't say, don't worry, this is only a chemical from a pepper. They send the same kind of warning signal associated with painful heat. So your brain interprets it as burning. And that signal is not imaginary. Capsaicin is a genuine irritant, and the nerve activity is completely real. The confusing part is simply what triggered it, a chemical instead of a high temperature. That also helps explain the rest of the spicy food experience. You might sweat, your eyes may water, your mouth produces more saliva, and your nose might start running. Those are real automatic responses to the irritation, even if your meal isn't literally cooking you from the inside. At this point, most people reach for water, and water can feel cool and provide some relief, but it usually isn't the most effective option. In one controlled study, both skim and whole milk reduced the burning sensation more effectively than room temperature water. Interestingly, whole milk wasn't clearly better than skim milk, so the usual explanation that milk works because it has more fat is probably too simple. Its temperature, proteins, sugar, and other properties may all contribute. But if capsaicin is setting off a pain alarm, why do people enjoy it? Part of the answer is exposure. When people repeatedly eat capsaicin, the same amount can begin to feel less intense. But tolerance isn't the whole story. Culture, familiar foods, positive memories, and how much someone enjoys intense sensations can all affect whether the burn feels exciting or simply unpleasant. So spicy food feels hot because capsaicin activates the same biological alarm used to detect painfully high temperatures. The food hasn't suddenly become hotter. There's no fire in your mouth. But as far as those nerve endings are concerned, someone just pulled the alarm. And that is the quick why.